An observer O cannot see the image of a target T through the mirror, so what is the minimum distance he should move to see the image of the target T through the mirror? And to answer this question, we're going to have to draw our light rays. And there are a few light rays we can draw. Basically, the whole idea is that our light ray has to come from our target. It has to bounce off the mirror, otherwise, well, you won't be seeing the image in the mirror. And it has to be able to reach our observer. So we are going to draw this light ray over here that bounces off the exact edge of the mirror, and that's the one that's going to give us the minimum distance. And I'll explain why in a moment, but for now, let's just draw the light ray. So another thing is that you'll notice that our light ray, well, it's going 2 squares to the left and 1 square down, 2 squares to the left and 1 square down. So after it gets reflected, it makes sense that it goes 2 squares to the left and 1 square up, 2 squares to the left and 1 square up. So if you look at our options, we are actually assuming in this question that our observer is only moving along the grid. So he's not going to end up moving over here to see the image of our target in the mirror, because this gives us a very weird number that's not an integer at all. So we are only considering about if he moves along the grid. So in order to see this, he will have to move 2 meters to the left, and B is going to be our answer. Now, if any of you are thinking, oh, he can just move 1 meter in front and the light from the target will be able to reach him, well, no, that's not going to be an answer for a number of reasons. I'm personally a little bit weirded out by that idea, because if you're talking about real life, his head is going to be blocking the light, and if you're not considering that at all, well, he's going to be standing literally at the point where the light strikes the mirror, and it's very hard to argue that the light there has even been reflected at all in the first place. So that doesn't work. Now, as to why this light ray gives us the shortest distance that he has to walk, well, the very important thing to note is that our light has to be reflected off the mirror. So if you have any other light ray, so maybe one that bounces off here instead, well, because walking forward this way isn't going to give you a light ray that has already been reflected off the mirror, he's going to have to walk to the left even more. And this light ray is going to end up being reflected, well, at a much larger angle, so he's going to have to walk much further. So basically, the light ray that bounces off the closest point here, this is going to give us our minimum distance, which is B.